Hi everybody, this video is about inscribed angles and we are following it up with a video about properties of chords. So here the learning objective is I understand how inscribed angles relate to intercepted arcs. We do have to start with some definitions: chord, inscribed angle, intercepted arc, and then we'll do a conjecture and two examples. So let's get started with the definition of a chord. A chord is a line segment with endpoints on a circle. And so you can see in both of these two circles, each one has a line segment and the endpoints are on the circle. Now, there are a couple properties here that we want to focus on. The first one is that a chord divides a circle into two arcs. And that's always true. So you can see here's one arc, didn't do it perfectly there. That's a minor arc. And the red one there is the major arc. Now, sometimes it so happens that the chord, this chord right here, runs through the center of the circle. So it makes that chord a diameter. A diameter is a special kind of chord that divides a circle into two semicircles. And so that's just a special kind of a chord there. So the two semicircles, they are both measure 180 degrees. So that is a chord. The next definition we need to look at is an inscribed angle. An inscribed angle is an angle whose vertex is on the circle and whose sides contain chords of the circle. So this right here is the inscribed angle. All right. An intercepted arc is an arc that lies on the interior of an inscribed angle and has endpoints on the angle. So in this diagram, our intercepted arc is right here, and here are those points that are the endpoints of the angle. The angle is right there, theta. All right, let's look at the inscribed angle conjecture, which says that the measure of an inscribed angle is 1/2 the measure of its intercepted arc. So another way of showing that is that this angle, theta, that is the inscribed angle. So theta is equal to 1/2 times the measure of, let me use a different color here, of this arc right here. And it's usually best if we label the endpoints, measure of arc A, B. So we have that very important inscribed angle conjecture. And you could also think of it this way. If we have this angle right here, and let's label this point C down here, then measure of angle ACB is equal to 1/2 times the measure of arc AB. Those are two ways of saying the same thing. All right, so for an example, in this first example, we can label this angle theta. So that angle theta is equal to 1/2 the measure of our intercepted arc, which is 166 degrees. And that will equal 83 degrees. The next one is a little bit trickier because we are not given the intercepted arc right here. However, we are given the central angle that relates to that intercepted arc. And that tells us then that this intercepted arc must also be 68 degrees. And now these endpoints are also the endpoints of our inscribed angle, which is right here, theta. So we have theta is equal to 1/2 times 68 degrees, which will be 34 degrees. And that is how we understand inscribed angles, intercepted arcs, and chords. More to come on chords in the next video.